Okay, it's 7 o'clock. Let's get going. I think people will keep trickling in, but thanks for joining. This is Portland Urban Beekeepers February 2022 meeting. My name is Ian Horvath. I'm the president of PUB, and we are speaking with Dr. Leo Shrashkin tonight on horizontal hives. So I have a little bit of housekeeping stuff to get through. I'll go pretty fast, and then we'll hand it over. Just a little shameless plug. If you're here and you haven't joined PUB, we appreciate it. It does include some benefits such as you get put on our swarm list, and we are upgrading the swarm call software this year. So we'll have more on that next month, but should be some better features to help us manage that. And we also have our Bee Buddy program, which I'll go over in a second, but it allows you to connect with local beekeepers if you're either a mentor or you want to learn from a mentor. And we have our bee days, which allows us to get together in person at the apiary over at Green Acres, and we can explore our hives. It's kind of an extension of the Bee Buddy program where we can partner up with mentors and learners and go through some of the stuff over there. We have a wide variety in our library, from candles to books and everything else. Equipment rentals are available, and then we have website classifieds you can post to. And most importantly, the money we collect, a portion of it does go to bee research. So that's really exciting. Last year, the board donated $20,000, and I hope to continue that tradition. So, all right, Bee Buddy program, for people who are not familiar, that's where we have a map where you can sign up and put your information on there. And you can either label yourself as somebody who wants to learn or somebody who wants to mentor. And then anybody can go on there, click and find your contact information, and you can partner up with somebody in your local area. So how do you sign up? Go to the website, click on resources, then click the Bee Buddy map. I have the direct link right here, which I will drop in chat for everybody. And you can go do that. Last month, we had a call out for anybody who wanted to submit for the OSU scholarships, Oregon State University scholarships. And so we selected as a board Jana Patterson. So Jana is our VP, and she'll be awarded this as well. So congrats, Jana, and have fun at the Oregon Master Beekeepers program. Maybe we'll have you give us a little talk about it at some point at the end of the year. Bee School, something else that we offer. This is 4 2-hour live sessions for the beginning beekeeper. So Susie, who is on the board, she's our education director or liaison. She runs these. She ran them last year, and I think even the year before. She's really awesome at them. So you get the 4 2-hour live sessions, and then you get time at the apiary just with her, Susie, and Dewey. And Dewey is actually the author of the textbook that we recommend for that class. So kind of a fun way to put everything into action when you're learning it as a new beekeeper. Bee School dates. So we have the date coming up. What is that, next week or the week after is the first date. So these are virtual sessions. So it'll be 7 to 9 p.m. and it'll be introduction to beekeeping, and then it'll be 1 a month after that. So, and I have the Bee School link that I can toss out there as well. All right. We met, I don't know, maybe 3 weeks ago at the apiary. Jana, Tim, and Bruce and I. Tim is over at Green Acres, and he runs that from the Green Anchor side. And then Bruce is our apiary manager. So the 3 of us met out there, and these are actually some of our hives out there right now, and then some of the other research hives that Oregon State University has. We were putting together our plan for 2022. So we think that 1 hive has died. We only have 2 out there. Well, kind of, we have 3, I guess. We'll debate on that, but we have a few top bars out there. We have 2 langs, and 1 of the langs might be dead, but essentially on March 6th, we're going to have equipment assembly and then first inspections. The inspection will be weather dependent. Obviously, if it's bad weather, we can't get into them, but cross fingers that it is not. And then March 20th, we'll be doing full inspections, depending on weather, and then really kind of sourcing ideas from the community and charting out the rest of our bee season. So how we want to manage the hives, we want to learn about splits. We can do splits out there. Want to requeen, anything you guys want to do, feel free to come out and join us. So it's kind of the in-person component to us being remote right now is a really great way to get out and meet other beekeepers. This is for beginners and advanced. If you want to come out and you've never been in a beehive, this is the place to do it, because you can sit next to somebody who's knows what they're doing and feel comfortable and safe doing it. So more details on that next month. We'll have a meeting right before the bee day in March 6th. So we'll have full details on that coming up. And it's a little confusing getting out there. So we're going to put this on the website, but this is the address and it's right next to the waterfront down here. This is the Willamette. You're not going to want to park at Green Acres. This is Green Acres right here. I'm assuming you can see my cursor. But you're going to want to park at Cathedral Park boat ramp. So you park here and then just come and walk out here and then walk all the way down until you hit this kind of these two buildings. If you miss these buildings and you hit the water, just turn around. So it's pretty easy to see. We'll have people out there and everything. And we'll put this on the website so you guys can reference it. And we'll also send out a reminder email the day before probably. So I wanted to share, so I think I know a lot about bees, but I discovered that there is a subspecies of honeybees called the Apis mellifera capenus, and it's a small subspecies that lives in South Africa in a very small area. And I thought it was super interesting, so I thought I would share it with you guys. So essentially what it is native to South Africa, and the workers, the female bees, are able to produce clones or pseudo clones of themselves. So they're able to produce other females, which can then produce other females. So I thought it was super interesting because, as we know, a typical honeybee, Apis mellifera, that we deal with in the US can only lay drones, right? So she can only lay males, but this Cape honeybee can lay females. And the super interesting part about it is that they cause what's called capenus calamity, where they actually will fly to other hives and they're accepted by these hives, and they will start laying eggs in their hives and produce more of themselves. They essentially pseudo clone themselves to the point where they cause that hive to collapse. And then before it collapses, they fly off to another hive and repeat the process. So I hadn't heard about it. I don't know how many other people had heard about it, but I thought it was very interesting, a very bizarre evolutionary trait for a bee to adapt. But yeah, thought I would share that as a fun little bee fact. So upcoming speakers, we have Dr. Leo tonight. In March, we're going to have Alistair on swarms, log hives, and bee lining in the forest. And then in April, we're going to have Brandon Hopkins. He's a research professor over at Washington State University. And he's going to be talking on queen caging as a way to control varroa mites. So pretty interesting stuff. If you have any other speakers or topics you want to hear, please just email me. We've gotten some in, so we're going to try to accommodate that in the coming months and schedule some of those speakers. All right. Without further ado, we have Dr. Leo Shorashkin presenting on horizontal hives tonight. So thank you, Dr. Leo, for being here. I will stop sharing and hand it over to you.
Thank you, Dan. Yeah, thanks again for inviting me to present. And my name is Dr. Leo. I'm originally from Russia. We have a beekeeper in the family. My uncle had been keeping bees since even before I was born, since 1972. And I grew up spending summers in his village looking how he keeps bees. And when I came to the US and eventually completed my doctorate in forestry at the University of Missouri, we bought a farm in the Ozarks in southern Missouri and started keeping bees, first just to provide my family and my children with the kind of honey that I was missing, and I could remember eating straight from my uncle's beehives. And gradually, because we were using methods that many of other beekeepers were finding new or unfamiliar, it went from there. There was more and more interest in the techniques I was using, completely treatment-free, only relying on the local resilient swarms for local genetics and disease resistance, and only using horizontal hives. That gradually I started doing more and more of beekeeping, and now it's a full-fledged profession and a full-term occupation for me. Now, I only have 40 beehives, but the principles that we will talk about today, both the natural beekeeping approaches that you can use in any hive model, and specifically how you can apply them to horizontal hives, the same principles can be used even on a commercial scale. Let me share with you a testimonial from one of my students who came to one of my two-day beekeeping classes a number of years back. So he took it to an operation with 200 beehives in 2 summers by setting out a large number of swarm traps. Actually, he set out 70, and he caught almost 100 swarms in 1 summer. And these bees had amazing survival rates. So 3 years later, he had more hives that he could possibly wish for. And he's selling bees, honey, nukes, queens, everything. And it all started by catching local swarms and tapping into this survival genetics that's accessible to almost anyone, especially in remote parts of the country, where the genetics of incoming bees is not diluting the local beekeeping stock. So my son once told me, "Daddy, look, everybody is upset about some sad news they keep hearing on TV, but nobody is happy about the wonderful things you do not hear about." And I think it really applies to honeybees, because even if you are not a beekeeper, and especially if you are a beekeeper, you've heard all of the stories about the colony collapse and mites and bees disappearing and being poisoned by pesticide. And at the same time, there are beekeepers in this country with hundreds and some of them thousands of beehives who've been completely treatment-free almost since bromides arrived. And you rarely hear about their experiences. So let's fill this gap. And over the next hour, I will share with you some of the principles that I've been applying here in the Ozarks, and also show you a few pictures of people who use the same techniques elsewhere. And then we'll also have time for questions. What I'm talking about today is not something new. It's not really good news that we can keep bees organically. This is how beekeeping was done for hundreds and thousands of years. And you didn't have to be specifically a beekeeper to have bees. In the old days, almost all farmers had beehives in the back of their yard just to provide honey as sweetener for the family and even to sell. So if you go to books written 200 years ago, you will have some of the statements that today sound completely mind-boggling. Look at that. This is from 1835 book, the Russian Beekeeping Manual by Vitvitsky, a Russian famous beekeeper of that time. So if you wanted to guess how many hives you could have that they would require very little effort to run, most people will say maybe 5, maybe 10, but once you get above 10, you don't really see beekeeping as an easy occupation anymore. But here is the quote from the original 1835 book. Peasant families commonly have 1,000 hives. You can go back to the same book if you read Russian. If you do not read Russian and you suspect there might be a typo there, the book being 200 years old, you can go and open the first edition of Langstroth's The Hive and the Honeybee, 1853. There is a chapter on beekeeping in Eastern Europe and Russia, and you will read essentially the same information. That many of beekeepers in that time, with no forklifts, without even more than beehives with frames, they were having huge apiaries, many of them several thousand hives at a time. So if these techniques were working 200 years ago, relying on the swarms, putting them in a hive, and they're not paying much attention to the bees, let's see whether this is something we can still apply today. But today the situation is very different. Even if you require bees for pollinating your cash crops, I took this picture at the local blueberry farm, most of the farmers will rent the beehives and pay a beekeeper to put bees on their farm for pollination. And when I asked this farmer why he didn't want to have a few hives of his own, he told me, oh, you know, I'd rather pay $1,000 to a guy, bring 5 beehives here when my blueberries are blooming, than mess with the bees myself. Do you see a disconnect here? 200 years ago, having 1,000 beehives was not considered something out of the ordinary. And today, having 5 hives that you need for pollinating your crops is so much work that people would rather pay a beekeeper to provide the service. Again, you go to books written even 100 years ago, 150 years ago, the same picture all over the place. Bee culture requires little effort and barely any capital to get started. Nothing could be farther from the truth today when you keep buying not just the equipment, but the bees and the treatments, and then you need to replace many of the hives again the following spring. And this is a vicious circle. And bee culture certainly is no longer an occupation that requires little effort on no capital to get started. But the old beekeepers were going as far as saying that God created bees so that even the most destitute of man could have his own little animal herd and find his solace. Where I live now in the Ozarks of southern Missouri, 100 years ago, modern Langstroth hives were not even known. Most people were keeping bees in kegs and in log gums, and they were not feeding them. They were not providing extra protection for winter, but 5 years out of 6, there was a honey crop to be had. You may object that 100 years ago, people didn't have to worry about the varroa mites or pesticide poisoning and other issues we face today. Well, it's partially true that today it's more challenging to have bees than it was in the past. But at the same time, if you look at wilderness, no matter where there are extensive pockets of wilderness, and even inside city limits, you will find feral colonies, wild colonies living without any of our intervention. I took this picture in Montana after teaching a course there one spring. I went hiking into this mountain ridge near Bozeman, and I could smell honey on this trail. It was still March with snow on the ground, but lo and behold, there was a colony of bees living in the Rocker cliff face, and the bees were already active, even at 50-degree temperature, because there was enough solar gain in the south-facing slope to get the colony going. I asked my guides, what kind of winters do you have here? The answer was, that winter was not too bad. It was -10 for only a week, and then it warmed up to 0. So there in Montana, here in the Ozarks, upstate New York, the research of Tom Seeley from Cornell University. No matter where you look in the wilderness, you will find wild colonies that are not treated with miticide, that live on their own with no sugar feeding or any other management. Some beekeepers believed that all of the bees we see in the wild today are just swarms that escaped from treated commercial apiaries and established themselves in a tree hollow in the woods, only to be killed by the varroa mites the next year. However, when a DNA analysis was taken of the wild honeybees living in the wilderness in America, or even in human structures in cities, like inside the walls, in attics and abandoned sheds, etc., they found that the genetics of these wild bees is substantially different from what we get commercially in bee packages or queens from the queen breeders. So they are really wild bees that are distinct from our semi-domesticated variety. And when Tom Seeley tracked the average lifespan of these non-managed wild colonies, he discovered, and that's reported in his book, The Lives of Bees, that the average lifespan of these colonies is more than 6 years once they're established. So what are beekeepers doing so wrong that And non-managed colonies of wild bees can survive for an average of more than 6 years with no treatments and sugar feeding and no management and no protection. And our hives are, if you use commercial bees and they're follow all of the prescriptions for keeping them alive, certainly rarely live to be 6 years old. Well, many beekeepers around the world were asking this question, and the basic approach of natural beekeeping is let's learn from the success of bees in nature, even today, 20 years after varroa mites arrived to this continent, and let's try to apply the same techniques that help bees thrive in the wild in our managed beehives. One of these beekeepers was Fyodor Lazutin from Russia. I had the pleasure of knowing him and visiting his apiary in 2010. He transformed his farm from crop growing to pollinator habitat. So this was his cash crop. He was planting shrubs and trees and annual flower crops to supplement the natural forage for his bees. He used horizontal hives with very deep frames to give the European dart bee, the subspecies he is using there, room for very rapid expansion in the spring. He only propagated his bees by swarming and planted at least 1 acre of wildflowers per each hive. So with his 100 beehives, he was planting between 1 and 200 acres of forage for the bees. And the only problem he had in his beekeeping operation, he told me, was not connected to honeybee health at all. It was marketing. He was producing so much of this wonderful, better than organic honey that it was a problem selling it on for the premium price and explaining to the potential customers just why it warrants the price that's higher than in the supermarket. Lazutin wrote a book in the Russian language called Keeping Bees with a Smile. And when I read it, it resonated strongly. And also I was not finding similar information available in the beekeeping manuals in the US at the time. So I served as editor of the English version, and now it's in the 2nd edition. Highly recommended. The principles of natural beekeeping, or what we would call today natural beekeeping, have not changed in centuries. If you open the old books, Georges de Layens, the famous French beekeeper, the inventor of the most popular horizontal hives that uses frames. You'll see pictures later in this talk. So he was saying that if you pick the hive model that is well adapted to your conditions and then populate it with local bees, then the results will speak for themselves. So let's talk about local bees, because this is the most important part of natural beekeeping. Where do you get local bees? If you go and buy it from a local beekeeper, that's not necessarily a locally adapted strain, because this beekeeper may be either ordering queens from elsewhere, or her or his genetic stock is coming from elsewhere in the preceding seasons. If you live in a place where there is an established, robust population of wild honeybees, especially living in the remote natural areas, they will be producing swarms in the spring. And if you set out some bait hives, swarm traps on trees in the springtime, for me, 50% success rate. For every 2 swarm traps that I set on trees in the springtime, 1 will get occupied by the local feral colony of bees. And I know for sure these are wild bees from the Ozark wilderness and not somebody else's, because I do take care to look at where the beekeepers are around, and I position my swarm traps at least 5 miles from any beekeeper I am aware of. There are very few beekeepers in the area, so the probability of catching the wild swarm for me is very high. And you can really tell by their behavior and especially their survival rates. So in the old days, this is how people were getting their bees. You set out a box in the tree and it attracts a swarm. Obviously, 100 years ago, beekeepers didn't have the luxury of ordering bees or queens elsewhere. 100 years ago, the Root Company first introduced selling packages and then queens that were sent by railroad. But before that, people were relying on getting swarms. The techniques and the practice of setting a box in the tree to attract a swarm was so old and so well known that I was reading Alice Through the Looking Glass by Lewis Carroll to my children as a bedtime story. And all of a sudden, I stumbled upon the mention of putting an empty box in the tree to attract the honeybee swarm and make honey. Imagine that children's books of today, 200 years ago, contained references to catching swarms, not just collecting them yourself, but attracting them to the hives strategically positioned on trees. Because this is an easy, inexpensive, reliable, and wonderful way of tapping into the local genetics of the honeybees, let me spend a few minutes describing the best techniques for catching swarms in swarm traps. If you don't take notes, you can read the free swarm catching guide on my website, horizontalhive.com. It lists all of these science-based principles of maximizing your success rate. Again, for me here in the Ozarks, it's 50% on average. Some years are better, some are worse. In areas actually where there are fewer trees left, like in Kansas, the first slide of this talk, if there are swarms, but they have fewer natural choices of cavities, your success rate can be even much higher than mine. So Tom Turner in Kansas consistently gets more than 100% success rate, meaning as he is replenishing the swarm traps that he is taking down with the empty ones, he would catch more than one swarm every season on average for every swarm trap set out. A very important point is the size of the swarm trap. Many people say they tried catching swarms in swarm traps and it didn't work. And if you talk more to these beekeepers, many times you discover that they were using a 5-frame nuke box or a smaller size or swarm catcher that's sold in bee catalogs that looks like a flower pot made out of wood pulp. So these containers are just too small for these preferences. Obviously, for a swarm, it's a matter of survival and life and death to pick a cavity that's big enough for them to expand and build all of their comb and to stockpile the reserves for the coming winter. So we know from Tom Seeley's research, Honeybee Democracy, that scout bees pay very close attention to the volume of the swarm trap and the size of the box that they give preference to, if they have a choice, would be somewhere between 10 and 15 gallons. One deep Langstroth frame is 1 gallon in volume. So a 10-frame deep Langstroth body is about the size, the smallest size of the cavity that the swarm would be attracted to. So if you put out a swarm trap, you can use a 10-frame deep box that you already have. If you are building special swarm traps, just make sure that the size is what the bees prefer. The way we know it is scientists put boxes of different sizes in the trees, and they found that 10 to 15 gallons is what attracts the largest number of swarms. This is pretty much the only implement I used for starting my apiary. We went from 0 hives to 40 hives in a few years without even making splits, by setting out these boxes in the trees and collecting swarms as they come. In addition to the right volume, a very important point is to put lure in there. The most ancient form of swarm attractant known throughout the world is propolis. The beekeepers in Africa today rely on propolis and some sweet-smelling grasses to attract swarms to their makeshift swarm traps. In addition to propolis today, it's a very good practice to take some slow-release tubes These are the plastic tubes that will release the attractant smell very gradually. Fill it with lemongrass oil. You don't have to buy the special pheromone lures. There was my article in American Bee Journal a few years back. We did a controlled experiment where 25 swarm traps were baited with the commercial pheromone, which is quite expensive, and 25 swarm traps were baited with lemongrass essential oil in the same kind of slow release tubes that our commercial pheromone comes in. And we caught more swarms with lemongrass, which is a fraction of the price of the pheromone lure, than with the pheromone. The reason for that is that the chemical composition is very similar. And as long as you use this plastic slow release tube, they're available very inexpensively on horizontalhive.com, and they are reusable. Then the success rate is increased tremendously compared to having a box that's not scented with anything or to using just propolis alone. Next, it increases your chances a lot if you put your bait hive off the ground at least 10 feet or so. The bees seek protection from predators and want to be farther from the moisture of the earth and the wet grass. So they have a marked preference to cavities that they find at least 10 feet off the ground. I've seen it with my own eyes. If you watch the scout bees discover your swamp trap, they will first go inside, and when they like the inside of the cavity and after they measure the volume inside the box, they will come out and they will be flying in spirals to the bottom of the tree and back up to the swamp trap, literally measuring how high it is off the ground. Nobody expressed this better than Winnie the Pooh, who said when he was climbing up this oak tree to get some honey from the bees, he was saying, it's a very funny thought that if bears were bees, we'd build our nest at the bottom of trees. And that being so, if the bees were bears, we wouldn't have to climb up all these stairs. So of course, bees know that the closer out to the ground, not just the bears, but also raccoons, opossums, mice, ants become more of a problem. So they're programmed to seek cavities off the ground up to like 10 feet or so. If your box is not just on a cinder block or on a hive stand on the ground, but actually is elevated, not necessarily in the tree like in this picture. It can be on the roof of your RV parked in your driveway. It can be on the second level deck of your house. Anywhere where you gain some height will increase the chances of a swarm discovering and also accepting this cavity. The species of the tree does not matter, but what does matter is that the box needs to be visible and not covered in branches. The scout bees are not really looking in trees that are all covered with dense branches because they are not very likely to have a cavity inside them. Instead, the trees that have a big exposed trunk are more likely to have a hollow in them, and the bees also see the big shapes like the forks and the bows coming off the main trunk of the tree very well. So anywhere where the tree has the trunk exposed, it would be much better than hiding it in the middle of the branches. At the same time, it's very important to prevent the box from overheating. Do not put it on the southern side of the tree. If there is no shade, at least put it on the northern side of the trunk of the tree so that this tree itself is shading the box at noontime. It may not be as important in Portland, but the farther south you go, the more important it is to prevent the overheating of the box by protecting it from direct sunlight. By the same token, do not paint it in very dark colors. Actually, it does help with preventing vandalism if you camouflage it or if you paint it in gray or non-conspicuous color. But the darker it is, the more solar radiation it will be attracting. And if the box overheats, the swarm is not likely to move in. The trees that stand on the edge of vegetation are much better swarm catchers than the same tree would be in the depth of the woods. An explanation for that is based in the honeybee's preference of flying through the open space. Imagine there is a patch of flowers behind these clump of trees. Instead of flying through the branches of the trees at full speed, it's easier for the bees to fly around them. So the bees like flying along the edge of vegetation. They use our highways and clearings for power lines in the forest, the edges of the fields for their own navigation. And because the scout bees are the same forager bees that had been foraging for nectar in the weeks preceding swarming, once they become scouts looking for a cavity to live in, they explore the areas that they're most familiar with first. And the edge of the woods or the edge of vegetation is what they go to first. And there are trees and the hedgerows like here on the edge of the woods, highways, power line clearings, parks, front and backyards, anywhere where the tree really stands out instead of being in the middle of the forest. Work really, really good. This I call, by the way, my I'll be darned tree. When I was hanging the swarm trap many years ago, few people in the countryside here in the Ozarks knew that swarms could be caught with swarm traps. And I'm there on the extension ladder, and I hear a truck stopping in the highway. The beekeeper, the farmer rolls down the window and says, "What the heck are you doing up here?" I was very nervous all the time when somebody was acquiring like that, because some of my swarm traps ended up being destroyed by gunfire, but I didn't want to stay in the path of the flying bullets. So I explained to this farmer that I'm just hanging a box to attract some honeybee swarms. He was amazed that you can actually get some free bees by getting a hive into the tree in the spring. So he said, "I'll be darned," and he drove off with no extra questions asked. The funniest part came a couple weeks later, or 3 weeks later, when I was collecting a very heavy swarm trap full of honeybees from the same tree. The same farmer happened to be driving on this road and stopped and said, "What the heck are you doing up there again?" I said, "I'm collecting a box full of honeybees and it's heavy." He said, "I'll be darned," and he just drove off. The word got out in the local community here that you can easily catch swarms. And 10 years ago, it was enough for me to knock on the door of a farmer and offer them a jar of honey in exchange for hanging a swarm trap on their land. But now many of them would say no. They went to my website and downloaded the free plans for building their swarm traps, and they build their own swarm traps. They realize, you just hang a box and it will give more than a jar of honey. Why not do it yourself? So I laugh because there are plentiful swarms here, and there are as many people as want to get into it and start catching swarms and rely on the local genetics of the bees. That's great. There are certainly plenty of swarms for me too. The orientation of the box does not really matter much. There is slight preference of the bees to the entrance of the box facing south, but so little that you will not really notice much difference. You can orient it the way it's convenient for you. What does matter too is if you happen to know where the swarm might be coming from. For example, I have a bee tree, or rather a bee snag in the woods on the neighbor's farm. I thought that since the bees were established in this that tree, by the way, the entrance was very close to the ground, I just strapped my swarm trap straight to this snag, hoping that the swarm will just walk from the mother colony into this new apartment next door. This never worked. If you look into biology textbooks, you will see that swarms prefer flying at least 100 yards away from the mother colony. So I did catch a swarm off of this colony, but not into the swarm trap that you see in the picture. In another swarm like that was a couple 100 feet away. Bees prefer to avoid competition with the mother colony for the same flowers and the territory, so they prefer to fly off some distance. So according to research, anywhere between 100 yards and a quarter of a mile is ideal distance to put your swarm trap if you know where the swarm might be coming from. For example, if you know there is a particular bee tree, or if you are trying to catch potential swarms from your own hives, 100 yards to a quarter of a mile. So that's it. The right volume between 10 and 15 gallons, preferably 10 feet off the ground, at least 100 yards from the known colony if you are trying to catch their swarm. Scenting the box with propolis and especially lemongrass oil with slow release tubes. The reason for the slow release tubes is that the bee's sense of smell is up to 100 times stronger than ours. So something that smells nice to us may be too strong for the bees. So these lab tubes have been calibrated to release the smell of lemongrass or pheromone at the concentration similar to what bees would have in nature. And also this way, you don't have to replenish this lemongrass oil. It will last the entire season. Timing, well, swarms start flying about 6 weeks after the first flowers start blooming in the spring. These 6 weeks the colony needs for building up enough new generation and brood to be strong enough to swarm. In terms of when to pull your swarm traps from the trees, I do so in mid-September, about 6 weeks before the first frost. I've caught swarms as late as early September. And if you give them a frame of honey, many of them survive successfully. So you caught your swarm. Obviously, you need to remove it from the tree after dark or after sunset, after all the foragers returned home. And you cover the entrance so there is air. Don't suffocate your bees, and but they cannot get out. In a pinch, you can even use a piece of duct tape and make some incisions there with a knife. I prefer using either wire mesh number 8 hardware cloth. It has 1/8 of an inch squares. The bees cannot go through that, but there is plentiful air. There are also special gates for your entrances that you can rotate and switch it from open to ventilation position. Then I bring it home, let them sit there with the open gate for 24 hours so they get used to the new location. Obviously, if the swarm trap was within the flight distance of the bee, for example, 300 yards from where you want the beehive to be, you cannot just move the swarm trap from the tree to the permanent hive location, because all of the bees flying out of the box would be returning to the tree where the swarm was. So either you need to put the hive right under the tree where you caught the swarm, or you need to bring the swarm trap from 3 miles away or 2 miles away. But anywhere in between, from say 20 feet to 2 miles, you cannot transfer them directly. You first need to take them away a few miles and leave them there for a week or two so they lose the memory of the placement of their swarm trap on the tree. And then you can bring them to the permanent hive location and transfer the frames and bees and the honeycomb they started building into a permanent hive. I have to transfer the actual frames because I use horizontal hives. If you use Langstroth equipment, and if you use a 10-frame deep Langstroth box, you just put it on a hive stand on the bottom board, and then you will be expanding it by adding additional boxes. If you do have to transfer frames and there are some bees still in the box, be careful because the queen can obviously be on the wall of the box rather than on the honeycomb. So don't just toss the bees into the grass. shake them on a piece of plywood leaning against the hive entrance, and they will go inside. As I mentioned, the late swarms I catch as late as September here in southern Missouri, zone 6. So when this happens, I take a swarm trap and just replace the wall with a piece of plexiglass and put them inside for the winter, connecting them to the outside with the 2 air hose. And you will see all of the cycle of development of the bees from just a swarm to a well-established colony the following spring. And I call it my BTV. And the programming they have there is plain amazing. I once even saw a drone arrive back to the beehive without the rear abdomen and with no penis. So this is the lucky guy who impregnated a queen, and most of them get paralyzed and die very quickly right there. But that one was just such a strong dude that he was able to make it back to his hive, and he died in this BTV. And I saw the funeral the following day, which of course for the bees that do not have the Veterans Administration to take care of it, dragging it out of the hive and disposing of it a few feet from the entrance. So this BTV I watched for many, many years, actually more than one. A year or two was the fall. I gave them 4 or 5 pounds of honey and they overwintered. The following year, they kept developing. In year 3, I saw all of the diseases you read about and you have probably experienced in your apiary. There were varroa mites and small hive beetles and deformed wing virus, you name it, wax moths too, in smaller quantity. But many beekeepers will tell you that deformed wing viruses are a sign that the colony probably won't make it through the following winter. Guess what? In year 5, this BTV colony was still thriving. Look at the pattern of their brood in the spring. They were just beautiful. So now when somebody tells me, oh, you cannot keep bees without treating them against the varroa mites because they will all die in the first winter, I say, well, it depends on the kind of the bees. But if you work in the with the disease-resistant wild strain of the honeybees that survives well on their own in the wilderness, there is no reason for them to die the first winter. So I know it because I've seen it with my own eyes on my BTV, and what they show you on TV must be true. All right, so local bees is the real foundation of natural beekeeping. No matter what equipment you use, or all of the other things are not as important as getting the bees that were honed by natural selection to coexist with varroa mites and the viruses that they transmit, and any other parasite or disease that we may have thrown at the bees. But even if you now have commercially purchased bees, there are so many things we can do to create conditions for them that would be approximating the kind of life experience they have in nature. So let me go over a few of the crucial points that apply to any bees and any equipment. Tom Seeley made the experiment in upstate New York by taking 2 groups of beehives, 12 hives each, and putting them in 2 different settings. One group of 12 beehives were in an apiary setting, like we put our hives a few feet apart, and the other group was spaced at least 100 feet apart, like in this picture. These were commercial bees with commercial Italian queens, obviously very little disease resistance or varroa mite resistance, and they were left alone for 2 years. After 2 years of the experiment, all of the colonies that were close together within a few feet of one hive from the other, they were all dead from varroa infestation. But of the same kind of bees with the same genetics, even all of the queens were from the same breeder, from the same genetic stock, half of the hives were still going with no mite treatments, just because the hives were spaced 100 feet apart or more. one of the explanations for that is drifting. The way mites drift from one hive to the other is riding on the forager bees that return to the wrong hive by mistake after foraging. The closer the hives, the more drift you will have. If you barely have a couple of feet between the hives, drift may be as high as 30% of the foragers. So if one hive has a very high mite load, it will spread to the rest of the apiary very quickly. The more the distance, the less drift. At the distance of 100 feet, there will be no drift whatsoever. Another venue for transfer of varroa mites from one hive to the other is robbing. Again, the greater the distance between the beehives, the more difficult it is for potential robbers to detect that one hive is not being protected well. So robbing is not as rampant the more the distance you have between the beehives. Well, if you do not have a way of putting hives that far apart, or it may not even be practical for you, what I do, this is a picture from my bee yard. I put them as far apart as practical for my situation, something like 20 feet apart. And also I follow Brother Adam's advice on avoiding drift. It actually goes back to George de Layens, at least, in France, more than 100 years ago. Do not put your hives in a straight line and orient entrances in different directions. It really helps bees recognize their hive, even if the distance is not as much as what they would have in nature. Another thing that really helps too is to put designs on your hives. Of course, for 100 years, beekeeping books have been recommending painting your hives in different colors, green and yellow and white, etc., to help bees come to their home. However, you probably know that some 20 years ago, it was discovered that the bees have a way of switching off their color vision. They use color vision on the flowers when it is useful to go from one flower to the other. But when they're flying at full speed, their brain is so small that they cannot process full color information at high speed. So they switch off the color vision to minimize the requirements for processing of this imagery in their brain. And then they see the world in grayscale. So your pink hive may look exactly the same as the light blue hive in the bee's eye when they return from foraging. So what works better is not necessarily designs that are as fancy as what my family put on our horizontal hives, but something that would be clearly recognizable in black and white. For example, if you have white painted beehives, take some electric tape and put symbols above the entrance. Do not put solid symbols like circles and squares, because bees do not distinguish the shapes of solid shapes well. Instead, they distinguish very well the branching patterns, like the letters of alphabet. X, they are really able to tell very easily from W, from F, from and other letters. So anywhere where there is branching is very easy for them to remember, and it will help more of the bees come back to their home instead of ending up in another hive, potentially spreading disease. Another experiment by Tom Seeley that showed that some things that make bees healthy don't really depend on their genetics is the size of the beehive. Again, the same kind of experiment. He had two groups of beehives. One group was held at just 10 Langstroth frames, 1D body, without expanding it, without putting supers or additional brood boxes. The other part of the experiment had 12 beehives that were managed the way we managed our hives, adding another box for the brood and then eventually supers. After 2 years of experiment, all of the hives that were supered or expanded were dead from varroa mite infestation. Again, they were not treated against the varroa mites with this experiment. But of the hives that you see in the picture, 5 hives out of 12 were still alive after 2 years with no varroa mite treatments, even though the bees were just the commercial stock. Again, here, the volume of the hive meant as much difference as 0 survival or 40% survival for the bees, even for the commercial stock. Part of the reason why colonies in small cavities are turned out to survive much better is that they will run out of room and swarm more regularly. And swarming induces a brood cycle break, both for the swarm that will have the fertile queen, but they won't have any honeycomb for a while for putting the eggs in. They will have no brood. The varroa mites will not be able to procreate until there is brood. And therefore, the mother colony that casts the swarm, they will not be fertile queen for a while. So again, the mite population will drop tremendously just because the varroa mite reproduction cycle has been disrupted. Many beekeepers rely on this almost exclusively for varroa mite control. Kirk Webster from Vermont, The Legend of Natural Beekeeping, 300 honey-producing hives and up to 500 nukes, will tell you that it is his experience that the smaller colonies will have a much better survival rate. So he breeds his own queens from his treatment-free stock for 20 years now. And at the same time, he is putting at least 1/3 of his apiaries through the state of a swarm by making splits and giving them new queens, but making sure that the colony will start small again. Small amount of brood means a less opportunity for the varroa mites to thrive. When I visited Kirk and spent a week with them 2 years ago, we were working bees from early in the morning until late at night. And in the whole week, I saw just a few varroa mites. And this was later confirmed by research at Cornell University. When they took Kirk Webster's queens, it turned out that the loads of mites in his colonies, all other things being equal, would be just a small fraction of what you would have in a commercial hive. Tom Seeley has it reported in one of his articles. You can look it up. Quite stunning. And Kirk Webster wrote a preface for the book Honey from the Earth, where you will read the same thing. Amazingly, in the parts of the world where there are varroa mites, but where beekeepers do not treat their hives against the varroa mites, the problem just doesn't exist. I was in Mexico. There are varroa mites in Mexico, but they don't treat, and there is no problem. Cuba, 160,000 beehives on this one island. The government doesn't allow the use of chemicals in the hive so they can sell organic honey to Europe. Again, they only rely on the genetics of the bees, selecting for the survival traits and the queens, and also on breaking the brood cycle to prevent the explosion of the population of the varroa mites. So this book, Honey from the Earth, is literally taking you on a tour of beekeeping around the world, 23 different countries. It's a 12 by 12 volume, and stunning photography inside, and also very educational because it expands your understanding of what's possible in beekeeping. So we covered the first part, the importance of local honeybees, and a few principles involved in the natural approach. There is much more in the 2 books that I edited, one translated from Russian, Keeping Bees with a Smile, and the other from French, this classical book by Georges de Layens, Keeping Bees in Horizontal Hives. Now let's talk about our hive choices. As long as you use local bees, of course, you can successfully keep them in different hive models, and so much depends on your local conditions and preferences. But I grew up seeing both vertical hives and horizontal hives in use. For example, my uncle has been using both models since before I was born. One thing I noticed is as he was getting older, there were fewer and fewer vertical hives left in the apiary. And now that he's 83 and still keeps bees, he only uses horizontal hives because obviously they require no heavy lifting. In parts of Europe, horizontal hives were very much part of the local tradition. And there are a number of books written by people who kept bees in both vertical and horizontal hives and could compare them side by side in the same location with the same kind of bees for 10, 20 years. One of these books is the book by Jean Urpin, the French beekeeper, only available in French now, but a fascinating read if you read French. He was describing his apiaries in about 20 years of comparing different hive models. And he is reporting that these horizontal Layens hive produced the largest harvest of honey for him, also with minimal effort. This is how European apiaries looked like in the end of the 19th century. Horizontal hives were predominant. And even today, probably half of Polish beekeepers use horizontal hives. There is more than 1 million horizontal hives in use in Spain alone. So it's not just hobby beekeepers, it is used even on a big commercial scale. I will show you a picture of the book called Raising Honeybee Queens by Gilles Ferte, the famous French queen breeder. He does queen rearing for a living, and he's describing his book with pictures and all that many of the commercial queen breeders in Europe use exclusively horizontal hives for his cell builders and for finishers, because opening them and finding queens and moving frames around just takes much less effort than unstacking the stack of Langstroth boxes, doing what you need to do, and then stacking everything back up. So with my experiences when I was growing up, looking at my uncle and other beekeepers using both vertical and horizontal hives, and all of the literature that you can read from Europe about the comparison about the two, I thought that, I will not have enough time or diligence to do all of the procedures that are required for good management of the Langstroth hive. So I went the route of these hives that were traditionally used for remote bee yards where you cannot get to your hives every 2 weeks. For example, Urpin describes how he had a number of bee yards far away in the mountains. The bee yards were not accessible by car. He didn't even have a car back then. It was the 1930s. He had a horse. So going on the mountain trail with a horse 30 miles is not the kind of the trip you want to take every week to check on your bees. So he had bee yards where he could only get there once a year. He would load an extractor and honey containers on the horse. He would go there in the bee yard, extract honey right there, return the frames to his horizontal hives, and he would leave the bees for a full year until the following September. And it was done year in and year out. Of course, today you will be concerned about finding a box full of wax moth cocoons if you didn't open your box for a year. I wanted to test it with the kind of bees I have here in the Ozarks that I know are thriving in the oak hollows or on their own. So I would take a swarm, put them in a box, and not touch them until the following spring. And this is typically what I discover. You will find a colony that's thriving. You can tell that the queen was and is prolific. There is bee bread. There is a very beautiful brood pattern, plenty of capped honey in the hive after the winter is over. This picture is taken during the spring inspection in late March, the year after this swarm was hived. They didn't even have foundational frames. This was a top bar hive. So all of this is pictures from the same hive. They had an equivalent of 14 deep Langstroth frames built out. in comb with more than 25 pounds of honey still kept after the winter was over. So after seeing hives like that, I was persuaded that if you work with the disease-resistant feral bees, then yes, you can do what beekeepers were doing in the old days. If you choose to, you can touch your bees much less than the conventional wisdom calls for when working the vertical Langstroth hives. One thing I like about our horizontal hives is this: because the bees are sitting in the same box and the frames are added laterally on the side of your cluster instead of building it vertically up, the bees don't have to go vertically up in the next box and then in the supers. So you can make the top bars with on the frames touching. And as they touch, like in this picture, when you open the hive for an inspection, you are not exposing all of the bees. The microclimate is not being disrupted. For example, during the spring inspection, like here, if you open the hive, it's enough to put the palms of your hands on the top bars of these frames without losing much heat from the hive at all. And you will feel that the top bars in the brood rearing area will be much warmer than the walls of the hives. So this quick inspection will tell you that they have brood and they're doing fine just by observing them at the entrance and then feeling the temperature of the top bars of these frames without opening up the brood chamber. When you add frames or when you pull honey, in this picture, the brood is in the top portion of the hive in the picture. What makes it convenient for horizontal hive beekeeping is the principle that was known as far back as the ancient Egypt. In a very long cavity, the bees tend to have the brood nest by the open entrance, and they stockpile honey away from the open entrance. One of the explanations for this is that more nectar and pollen is actually used by the bee colony to feed the brood throughout the season. So brood is the largest consumer of the resources, and it is just economically more feasible to position it by the open entrance. This way you don't have to transport all of the nectar and pollen through the depth of the hive to feed the brood. Having the brood by the open door minimizes the amount of traffic and congestion inside the hive and also makes ventilating and temperature regulating the nest easier for the colony. So if you do bee removals and you have bees living in between floor joists in the building, you will often see the same thing: dark honeycomb by the entrance hall, wherever it is, and then there is a boundary as if there was a queen excluder, even though horizontal hives rarely require one, and the bees are stockpiling honey away from the brood's nest, away from the open entrance. So with this setup, again, in the ancient Egypt, they were making cylinders with the entrance at one end of the cylinder made out of palm leaves and mud, and there was a plug in the other end of the cylinder. So the bees would make the brood nest here and stockpile honey in the end of the cylinder, and the beekeeper would be opening that plug and harvesting honey here without reaching the brood nest. The same today is done with the movable frames. So in this picture, I'm pulling honey from the honey section of the hive without having to go into the brood chamber. Vice versa, if I need to check the brood chamber, for example, if you suspect disease, I'm able to pull one frame from the brood chamber without having to remove supers from my hives. This picture I took with my friends in California when they were finding the queen for their queen rearing purposes. They had an average of 6 boxes on each hive, and they had to get to the brood chamber by removing all of the boxes, putting them on benches in 55-degree weather. Then you find the queen, you do what you need to do. It takes maybe another 10 minutes, and then you stock everything back together. That's a lot of work and a lot of disturbance of the bees. The microclimate is compromised too. You risk chilling the brood and all of the other disadvantages of exposing the brood chamber to the cold weather. This is largely avoided or completely prevented by using horizontal hives. If you have Langstroth frames, you can build a long Langstroth hive. There are free plans on horizontalhive.com. If you would like to experiment with this style of beekeeping, you just make one long box that takes Langstroth frames. In the cold climate, you can cover the gaps between the frames with burlap. This is not something I recommend anywhere where there are small hive beetles, because the small hive beetles will hide between the top bars and burlap. In this case, it's best to cover the gaps between the frames with the propolis collectors. Not only it will create this barrier that will prevent all of the bees coming through all of the gaps between the top bars when you open the hive for inspection, but also the bees will fill these screens with propolis, so you will harvest possibly a pound or more of propolis per beehive at the end of the season, just by covering it with propolis collectors instead of burlap. One unintended consequence of this approach is that because you don't have to go into the brood chamber often, and you may have noticed that bees don't mind you opening the supers as much as they mind you going into the brood chamber. So I add frames on the side of the brood chamber in the spring. I harvest them on the side of the brood chamber in the fall. And because this is done without opening up the brood chamber, and because the number of time between the hive visits is so great, commonly 2 or 3 months between the visits, that the bees don't have the memory of the disturbance, they become very gentle. Not because I am a bee whisperer or have some special super gentle strain of bees. No, they can be ferocious. One of my neighbors are 50 miles away is a beekeeper using similar techniques. He catches local swarms here in the Ozarks, and they're treatment-free, but he uses conventional Langstroth hives, and he goes into his hives about once every 10 days or 2 weeks during the season for management purposes. So his bees are ferocious, and my bees caught in the same woods are very gentle, just because I keep disturbance to the minimum. And this picture was not for the show. As you can tell in the background, I do bring all the protective gear with me, the veil and the bee jacket. But most of the time, me and my children do not have to wear protection, because by the time we pull honey in the fall, first, the population in the hive is really small compared to the height of the summer. By the way, this is another advantage of having just one big long box. Instead of harvesting at the peak of the hive activity, I can postpone harvest until late in the season, after they are winding down for the winter. The bees go back to the brood chamber and start to form a cluster after the first frost. So at that time, the honey frames in the back of the hive are almost abandoned. And when I take them out, there are barely any bees left, and the ones that are there behave very, very gently. My daughter, Lada, daughter of a beekeeper, was on the cover of Acres USA magazine, and she never was stung by a honeybee once in her entire life. I don't mind getting a sting or two here and there, but again, it's really a very pleasurable experience going to the bee yard, because keeping the disturbance to the minimum removes much of this very hot, aggressive, defensive response from the bees. Another benefit of horizontal hives, because they're stationary and you are not lifting or moving them, you can build them double-walled and insulate the lid, the wall, and the bottom once and for all. It's especially important for climates with cold winters or hot summers. Here in Missouri, we have both. We have very hot summers, and winters can be down to 0 degrees. So I build my hives are either very thick solid wood, and I also have plans for that on my website. My favorite way of insulating the hive is making them double wall with a wool, natural fleece in the wall for insulation. It protects the bees not just from the cold in the winter and from the heat of the summer. Very importantly, it's also protecting them from the swings of temperature in the spring. Get a copy of the Lives of Bees by Tom Seeley. There is an amazing graph there when he is showing that in a hive that has no insulation value, in the spring, the temperatures can go by 30-degree or more difference between the daytime and the nighttime. And of course, it requires much more energy for the bees to regulate this compared to the very well-insulated cavity that maintains the stable temperature on its own with less effort by the bees. Also, when the box is not insulated and it warms up in the sun during the day in the springtime, it causes bees to start rearing brood prematurely. So there may be 85 degrees during the day and 30 degrees at nighttime, and all of that brood that they've started rearing may not be covered by the cluster of the bees at the nighttime. Then you have brood disease, chalk brood, etc. So that is largely avoided by having well-insulated beehive, and you will see it with your own eyes. So this is a picture of a double wall hive with 1.5 inch of our fleece insulation in the walls on a day in my apiary in southern Missouri with 100-degree weather, extremely hot. And there is something you see about this hive. This hive and the other hive in the same apiary, there was no bearding. It's inconceivable to see a hive or just a regular Langstroth with 3/4 inch walls on a 100-degree day with bees not bearding. But this is common for the hives that are positioned in partial shade and have 1.5 inches of insulation in them. For the sake of comparison, I built a hive out of 3/4 inch wood, and here is a picture of that hive in the same apiary on the same day. That one, of course, was boiling over with the bees. So after this experiment, I saw with my own eyes that the amount of insulation really matters for the bees. If you live in a climate where there are no harsh winters, it will still benefit you for protecting the bees from overheating in the summer. And interestingly, you may not know that Langstroth himself invented a beehive that was double wall, and there was supposed to be insulation placed between the two walls. If you look up the blueprints for the patented Langstroth hive, at least what he invented, it was a double wall hive. So what we call today the Langstroth hive is just the inside box, and the outside casing has been discarded for the ease of manufacture and the lower price of it. But again, Langstroth himself was promoting double wall, well-insulated beehives. And ironically, the hive that bears his name today is not the kind of the hive that he envisioned and promoted for keeping bees in. Let me say a few words about the size of the frames too. In nature, bees live in narrow and very deep cavities. Actually, they cannot leave a cavity that would be 3 feet across, even if they were to find it, because they need the support of the walls of the cavity for supporting the honeycomb. Obviously, the bees cannot build their honeycomb 3 feet wide and indefinitely deep, because the attachment to the walls will not be strong enough to prevent this tremendous honeycomb from sagging in the middle and collapsing. So the magical number, it's based just on the structural integrity of the honeycomb, is 14 inches. So if it's 14 inches or less wall to wall, then this cavity can support the honeycomb no matter how deep it is without collapsing. Our frames are much wider. The Langstroth frame is 17.5 inches on the inside, but this is not what bees have in nature. If you look at the reports of people going into the woods and opening up the bee trees, you will probably not find any reports of bees living in huge hollow trees with 2 or 3 feet of hollow inside. Most of the time, we will see 10, 12, 14 inches across. The 19th century European literature of honeybees gives this number between 10 and 12 inches is the size, the diameter of the hole that their beekeepers were finding with the wild bees in the woods. So in this book, written in Russian, that's referenced in Keeping Bees with a Smile, they were making a cutout from a tree that they felled in the woods. They needed to transfer that colony into the managed beehive. So not only they harvested 10 buckets of comb honey in the process, but they filled the 12 deep frames with brood. And then when transferred into the movable frame hive, the colony built 12 medium frames of new comb in 36 hours. The Lane's hive that I use, this is this classical horizontal hives. Not only the frames are on the same level, making it easy to manage, but also the frames take the shape of a tree hollow. They're 12 inches across, but 16 inches deep. And when you look at the frame like that, you see the same pattern that you would recognize if you were to open the bee tree in the woods. There is the header of honey above the wintering cluster, and they leave empty cells underneath where they will cluster for the winter. With this setup, the colony will be moving vertically up, consuming honey during the winter, which is much preferable for them than moving laterally. Not only there are no gaps from one frame to the other because all of the honey is contained on the same frame as the cluster, but also as they're moving up rather than left or right, the heat of the cluster is preheating honey for them and reliquefying it gently before they even reach the particular cell and uncap it. So it's a tremendous saving of energy, and this is how the bees navigate during the winter. They do not have a mental knowledge of where honey is stored. They go to where there is honey and there is warmth. In a narrow and deep frame like this classical European Layens frame, the direction of movement is the same. You go up, you have honey, and you have warmth. Because the top bars touch, there is no loss of heat vertically, and the bees have this warm dome of warm air and honey at their disposal for successful wintering. I do use foundation. I get my Layens foundation from Spain in the mountains where they do not put bees on commercial crops, and this is the purest I could find. But also I make sure I give bees the freedom of raising as many drones and building a few frames foundationless. So I found that the most reliable way to start a foundationless frame is a strip of foundation 3 inches deep. Very good results, very straight honeycombs, and there are very few comb collapses. No comb collapsing in the well-insulated hive put in partial shade. So that's how we keep bees, and then the time comes to pull your frames. I did, after establishing the apiary here in Missouri, try different styles of hives: Langstroth, horizontal Langstroth, Warre, Layens. But after trying Layens for a number of seasons against the frame 12 by 16 deep, I saw that the survival was better in the winter. The development in the spring was spectacular. And that eventually I transferred all of the bees into laying-hens equipment, and this is what I keep the bees in now. This size of frame requires a special extractor. I first got it from Europe. Now we also sell it on horizontalhive.com. If you use this size of the frame that doesn't fit into Langstroth equipment, but it's a very good machine and holds its value. You can use it for 20 years and then resell it for about the same amount of money you paid for it. And I'd like to close this presentation by mentioning that, when we talk about natural beekeeping, we may be talking about the strain of the bees and your beekeeping practices, and they're being treatment-free, and they're having well-insulated hives, etc. But certainly, another most important part of natural beekeeping is natural environment. We live in the part of the country where there is still a lot of wilderness left. Not only it provides the bees with very diverse or pesticide-free forage in the woods, but also it provides a way for local beekeepers to take advantage of the wilderness without converting it to pasture grazing or to other uses. I find it inspiring that here in the Ozarks, as a beekeeper, I can produce more in terms of economic value from honey with native vegetation, our beautiful shrubs and trees. This is my #1 honey crop source, sumac. It produces huge amount of nectar, so much so that when sumac is in bloom, the bees will stop visiting white clover around here. So I'm able to produce more in terms of economic value from 1 acre of sumac brush than any farmer could do by brush hogging it and trying to run cattle on the same amount of land. Here in the Ozarks, it's very dry and hot in the summer. The soil is rocky and shallow, certainly not prime agricultural country. And bees help those who need to provide for their families through the use of their farms with a non-destructive, very economical and profitable way of sustaining themselves and feeding their families. If you'd like to learn more, I teach beekeeping classes right at my apiary. It's a full 2-day course. You can read the program on horizontalhive.com. But we have people coming literally from all over the country. I know that a trip all the way to Missouri may sound like a long ways to go, but we had people fly in from even India to attend this course. Usually there are people from about 12 or 15, even 20 different states coming together. So not only you will enjoy the program on this natural treatment-free beekeeping and horizontal hives, we will spend time in the apiary looking at the bees, but also you will meet a group of 50 beekeepers from all over the country that share the same vision. The next class coming up is April 9th, 10th, 2022. So if you're interested, you can find more information on horizontalhive.com. Again, there is much more in the 2 books I mentioned, Keeping Bees with a Smile. These are the natural beekeeping principles and how they play out in horizontal hives. And the other one specifically, if you are interested in learning more about the management of horizontal hives and how a robust honey crop can be brought with much less effort than what we're accustomed to in the Langstroth hive, then read this classical book. It was written first in 1892. But today it is as relevant as it was back in the day. Layens wrote it, Keeping Bees in Horizontal Hives. All of the books I'm showing are the ones that I edited, Russian and French translation. Here's the other one I mentioned during the talk. When I was giving a talk in England, I asked them what they considered to be the best a queen rearing book. And they said this was the book by this French queen breeder. I read the book in French, and it is amazing because there are full color pictures and diagrams on every page. And if you never reared queens because you thought it was something super complicated, this book really walks you step by step through different techniques. You can choose your level anywhere from raising a few queens and using very simple methods that do not require grafting or any special equipment. But the book also shows the techniques for professionals who want to raise hundreds or even thousands of queens. The afterword was written by Kirk Webster from Vermont, this treatment-free beekeeper who produces not only over 1,000 queens from his own stock in the mountains in Vermont, but also produces between 30 and 40,000 pounds of honey. It's just, again, one-person operation, 30,000 pounds of honey, treatment-free for the last 20 years. Again, if someone tells you that, oh, treatment-free is impossible, well, it depends on what kind of bees you have, where you live, but there are examples certainly across the country, like Kirk Webster, who do it even on a big commercial scale. He is also in Honey from the Earth book, so that is the book that shows you how bees are kept today throughout the world. It's almost like reading a history book, because in some parts of the world, people still use the log hives like this in mountains of France, honey hunting and rooftop beekeeping throughout the world, and even tropical honey bees, not Apis mellifera, but other species that produce honey are covered in that amazing book. And it was all shot by the same photographer who spent 15 years traveling to 40 different countries. It's a fascinating journey across the world that even talks about honey ants in Australia that gorge themselves on honey and produce honey. So what you see in the picture are the actual living ants. You may not have heard about other insects other than bees producing honey, but there are species of ants that gorge themselves on honeydew or nectar so much that their abdomen swells, like here in the picture, so they become living barrels, and the Aboriginal people dig them up and eat them by the handful. My most recent publishing project is the book of honeybee biology. If you read The Buzz About Bees, this wonderful book by the German bee scientist Jürgen Tautz, he is a co-author, and stunning 12 by 12 inch photography throughout. So a book on honeybee biology, but with stunning photography that you will not find anywhere else. Also, I mentioned swarm traps and horizontal hives. There are free plans for building all of the equipment that I use, both for Layens style with this frame like in this picture, and also for the Langstroth style. So if you want to build a Langstroth horizontal hive or swarm trap at minimal expense, you can look up free plans on horizontal hives. If you want to buy any of that equipment or the slow release tubes for your increased swarm catching this coming spring, they're also available inexpensively on the website. And I'd like to conclude by sharing a dream that my son had. He once told me, "Daddy, I saw 1 billion bee colonies in my dream." I said, "Wow." He said, "Daddy, but it was not the most amazing thing, because nobody sprayed them with pesticides. Not a single bee died. And they made so much honey, it lasted them 1 billion years." So that's the vision I have. You know, I do beekeeping not just because it is livelihood, because it provides me with income. It really puts a smile on my face, and you get to live your life outdoors, are surrounded by the buzzing of these amazing creatures, and a dream of the sweetness and children's laughter persisting for 1 billion years. Thank you for your attention, and we have time for questions too.
Awesome. Thank you for that. I really appreciate it. That was a lot of information. And yeah, it's always interesting to hear about different types of beekeeping from different areas of the US. It's so vast. Jana, do you want to manage our questions in the chat, please?
Oh, sure, no problem. First, I just want to say thank you, Dr. Leo. That was really very interesting and really amazing. So I really appreciate all that information. The first question we had in our chat is from Kevin, and he wants to know how you get your swarm traps down from so high up in the trees.
Oh, thank you. It's a very good question, and sorry I didn't address that. I just take it under my arm and I carry them down the extension ladder from 20 feet up in the tree. However, if you do not feel confident, and by the way, I only fell twice from my ladder after handling hundreds of swarm traps over the years, but there is a simpler way to do it. Both for getting the box into the tree and for getting it off the tree, you can use a rope. You run the rope under the top of the swarm trap, and then you just throw it over a branch and just pull it up like on a pulley. And then once it's up there, you can climb up on the ladder and put a ratchet strap attaching it to the trunk of the tree. When it's time to bring it down, again, remove the ratchet strap and just pull it down to the ground just on a pulley by releasing this rope slowly. By the way, you don't even have to go up there on the ladder. In upstate New York, where there are black bears in the woods, many of the swarm traps get destroyed if they're attached to the trunk of the tree. However, they found that if they put them up on ropes from a branch, then the bears cannot reach the swarm traps. So they use two ropes. One rope is to hold the top of the hive, and you just pull it up until it's up there. And the second rope is an anchor that goes from the bottom hive to the stone on the ground or some piece of vegetation to prevent it from spinning. If it's moving a little bit in the wind, it does not deter the bees from accepting this cavity as their new home, because even trees themselves will be swaying in the wind. So a little bit of the movement is fine. And again, if you are not comfortable going up in the tree on the extension ladder, you can use the rope.
That's great, thank you. You already answered my question about where you get the slow release tubes for the lemongrass oil. Sounds like we can find them on your website, so that's great. You touched on this question a little bit. Martin asked, are the walls of your hives insulated?
Yes, this hive is just for a show. It's built out of 3/4 inch material, but the actual production hives that I use are either built out of solid wood, 2x material, so 1.5 inches. This is already twice as thick as the Langstroth hive, or mostly I use the hives that are built out of 2 layers of formaldehyde-free plywood, 3/8 of an inch on the outside and the inside, and they have 1.5 inches of wool inside the walls, which gives an R value of approximately 6. For comparison, the R value of a Langstroth hive is 1. So I give my bees about 6 times as much protection as the conventional Langstroth hive. Again, if you go to horizontalhive.com, it's not just the plans. You have a building guide for each of the hives. You can see how this insulation goes in and how it walks you step by step by building these insulated hives. Again, I'm not the one to invent it. I just use the techniques that are described in the old literature. The person who set up the mass production of the thin wall, uninsulated Langstroth hives in this country, Root, A.I. Root, and his company in Ohio was the largest manufacturer of Langstroth equipment back in the 19th century. He wrote a very beautiful book, his autobiography, which I highly recommend. And interestingly, he was manufacturing these thin-walled hives commercially just because they were cheaper, and he understood that people were looking for some, inexpensive beekeeping equipment. But in his book, he talks about the importance of insulation, and he says that he, in his own apiary, obtained the best results from his bees when he was giving his bees a huge amount of insulation around the box. He was using chaff or rice hulls or other similar material. Langstroth describes in the first edition of his book that many beekeepers were piling wood chips around their beehives for the winter, making a mound like an anthill, and putting up to 12 inches of material around their beehives. And this was providing wonderful results. Again, all of these ideas of beehives that are well protected, something that you will find in nature. The bees are very well insulated and inside the bee tree. All of these ideas stem back from the grandfathers of modern beekeeping from the 19th century.
Thank you. Our next question is, do you use a divider board or something similar to limit the size of the brood nest and ensure the queen is not laying on the honey frames?
Wonderful, thank you. Yes, the divider board is very important in the horizontal hive because, for example, the hive you're looking at has the volume equivalent to 5 deep Langstroth deeps, 50 deep Langstroth frames in terms of volume. Wow. So when you're first installing a swarm or a package, I never bought bees and I do not recommend package bees. But if you install a swarm or a package, huge amount of volume is not something they can heat. When they just start, they really need to have a very snug cavity. Part of the reason is this: when the colony is building new honeycomb, they need to elevate the temperature because they can only work wax and make it malleable if the temperature is high enough. So the smaller colony can only do it in a smaller volume. So you do have a divider board, which is just a piece of plywood, and you limit the size of this box first to say 6 frames. And you do not give bees more room until they build out all of the 6 frames, at least 2/3 down. Then you slide the divider board sideways, and you don't really need to go into the existing 6 frames that are there. Just on the side, you add 2 or 3 more frames and you put the divider back in. And you gradually grow the colony like that in the first year. Yes, this makes for more frequent hive visits, but it's not a hive overhaul. You're just opening the side of it. All of the frames are fit together, so the bees don't even know that you open it. You put a few frames, it takes 30 seconds and you're done. In terms of the queen excluder, it depends a little bit on the strain of your bees. With the local bees here in the Ozarks, I'm finding that this principle of them storing honey away from the open entrance and having brood by the open entrance holds. So for example, in this picture on the screen, this long slot would be blocked throughout most of it. So there would only be an entrance on one end of the hive, maybe 6 inches wide. The rest will be blocked. So by the open entrance is where they will have the brood. And without any use of vertical queen excluder, the queen will stay by the open entrance, and this is where the brood chamber will be. You know that for the bees, it's very difficult to heat the brood, and actually they avoid spreading the brood chamber too far, because if they were to scatter brood on, say, 20 frames, a little bit on each frame, then the shape of the brood cluster would be so long that it would take many more bees to heat and protect it and feed it than it would take when it was more in a spherical shape. So for this reason, even without a queen excluder, as long as you keep adding frames or for the queen to continue laying, you don't need to use one. She will stay by the open entrance. This is with my bees, though. Now, the Italian honeybee that predominates commercially in America, so 70% of the queens and bees sold there as package bees are the Italian honeybee. They come from the climate in southern Italy that is so mild, and the growing season and blooming season is so long that they, the Italian honeybees are known for the tremendous amount of brood production that they can sustain. So if you have a queen of the Italian strain, you probably will want to use a queen excluder vertically as a divide in your hive. So put 10 frames of this laying style for the brood chamber, then the vertical queen excluder, and then the rest, because the Italian queens can keep going and going and going. And I sometimes heard from people who had Italian package bees installed in horizontal hives, and the whole hive had brood on all of the frames and very little honey at the end of the year. With my wild bees in the Ozarks that have a lot of European dark bee, the black bee genetics, some of the bees look like they look in England. This is the very dark bee with no yellow stripes, just black and light gray stripes, but no yellow. So because there is a lot of these black bee genetics still in the wild, they have that more conservative approach to brood rearing. The European dark bee comes from the north of Europe, so they know that the season is shorter and they cannot afford scattering brood through all of the hives because it will be chilled. So with these bees, I do not have to use a queen excluder, and there will be this clear separation of honey from brood as if I was using a queen excluder. By the way, there is one more technique described in keeping bees with a smile that is very old for preventing the queen from going into the depth of the hive and staying on the brood frames only. In nature, when the bees live in a cavity, they have the brood cluster, then there is honey above them, and there are also two curtains of honey on each side of the brood cluster. So the honey goes above and to the side of the brood cluster. And then beyond these two curtains of honey on the side, there is just the wall of the cavity. For this reason, and that's described in the old books, the queen is programmed to stay in the brood cluster. And if she reaches the honeycomb that only has honey there and no empty cells for her to lay in, instead of going behind that honeycomb, she goes back to the center of the brood cluster where there is brood and where there is higher temperature. Because in nature, if she was to go around this last honeycomb, there would be the wall of the cavity and nowhere to lay. Because the bees don't know that we transfer them from the bee tree into the hive, the beekeepers back in the 19th century, when the modern queen excluders were not yet available, were readily using this principle. If you want to limit in a horizontal hive the number of the frames that the queen will be laying on, say you want these 10 frames for brood production and the rest for honey, what they would use would be taking 2 full frames of solid honey and putting it there. And this was acting as a queen excluder, essentially. The queen would go from the brood cluster to the frame, and there are no cells to lay in, it's just solid honey. Even if she goes on the next frame, it's solid honey, and she gives up and goes back to the brood cluster. And finally, one way of preventing queen from laying in the depth of the hive in the honey section without a queen excluder is to increase the distance between the honeycombs by inserting 1/4-inch slats between the top bars. So my frames are 1.5 inch wide, which is typical in Europe. Instead of 1 3/8 inch wide like the Langstroth, they're 1.5 inch wide. So if you spread the top bars by 1/4 inch and you put 1/4 inch slats between them, you increase the spacing of the honeycomb up to 1 3/4 inch spacing. And this is so wide that the bees will extend the cells and make the honeycomb thicker. And it being so thick, the queen will not be laying in it, because the queens do not lay in very deep cells where she cannot reach the bottom of the cell with her abdomen. So these techniques have been traditionally used there to prevent queen from laying throughout the hive. Again, today we can use a queen excluder, but most commonly in the past, people were just relying on the northern genetics of the bees, on using 2 frames of honey instead of the queen excluder, and finally increasing the spacing between the combs in the honey section, something we use in Langstroth hives too. Instead of 10 frames, you may put 9 or even 8 in your supers. They will be thicker, and even if there is no queen excluder, the queen is not likely to lay eggs in these very thick combs.
It's very interesting. Thank you. Our next question says, besides the entrance, do you have any venting in the long hive?
Wonderful. The amount of ventilation you need is really proportional to amount of insulation. And this is something that you read about in 1853 book by Langstroth. There is a chapter on the importance of insulation. And think about it, inside the bee tray, most commonly the bees have only one opening, the entrance, which is relatively small. It's usually less than 2 square inches in diameter. Anything else they will block with propolis. So they have less than 2 square inches of space, both for all the traffic and for ventilation. And they do not need any more. If there is any additional crack or opening, they will propolize it. We know it. So inside the bee trees, you are not finding moisture or dampness or problems with ventilation, even though the amount of opening is very small. So why is it? Well, the answer is this. The amount of insulation and thermal mass you have inside the tree is so great that condensation cannot happen on the walls of the hive inside the bee tree. The air may be moist, but it's not what's hurting the bees in the winter time. It's condensation, when this moist air actually forms condensation on the walls, on the honeycombs, and they become moldy. That's the problem. So if you have so much insulation that there are no cold surfaces inside the hive, then this moisture cannot condense. In the summer, it's the same principle. The better your hive is insulated, the less the bees have to ventilate it to maintain the required temperature. And it also means that the small amount of opening is sufficient. So I usually have just one entrance open, which is 1.5 inch diameter hole for the winter. And in the summer, if my hives are in full sun, but most of my hives are in partial shade, but with the hives that are in full sun, there would be an additional vent in the top portion of the hive for ventilation. So for example, here in this picture, if you see my cursor, if the entrance, the main entrance was at the bottom of here of the central wall, and there are 1.5 inch diameter hole. If this hive is in the sun, then in the top portion of this wall, there would be an additional vent that's open for the summer only, that allows them to drive air through the hive and out through this additional vent when the weather is very hot. I only really need to have a vent here and open it for hives that are in the full sun. But if they are in the full sun, even the insulated hives will require a top vent during the time of the strong honey flow.
Is that vent something that the bees can come and go? Is this like a top entrance, or is
Oh
it?
yeah, it's a, yes, thank you. Yeah, it's just another entrance.
Okay.
And for example, in Spain, where these horizontal hives are very widely used, they make two entrances that are in the middle of the box. One is about 1 inch from the bottom, so the bottom entrance, and the other one will be probably 6 inches from the top of the box in the center. And they have it, the top entrance open during summer only to provide cross ventilation. Again, this is because my beehive is not as well insulated as a natural tree cavity. If I had the walls that are 6 inches thick with insulation in them, then I wouldn't even need a second vent even in the full sun. But because making hives with 6-inch thick walls would be very natural, but not very practical, it's difficult to carry them and install them, and quite expensive to build, it's a compromise. And that means that, yeah, sometimes you will need to give bees more ventilation that they would need inside a natural bee tree.
And our last question in the chat says, do you use smoke to calm the bees down?
I use some smoke. I always have the smoker going when I go to the apiary. But depending on what I do, I may or may not use any or a lot of smoke. For example, I mentioned that one of the benefits of having a large volume hive where honey is stored away from the brood chamber is that I can delay the honey harvest until the fall. One of the benefits is that at that time, the population of the bees is really small compared to the summer. Also, after the first frost, they start forming the cluster, and there are very few bees left in the section where you pull honey. So during that time, I don't really need to use a smoker at all. If I had any need to open the hive in the middle of the summer, I may need to use some smoke. I have no problem with using smoke. I know that for the bees, it's actually less disturbance to receive a puff of smoke and not pay too much attention to you after that than to not receive any smoke and then have all of this release of alarm pheromones that linger there maybe for days after you open the hive. So yeah, I use a little bit of smoke. Don't overdo it, but very little is usually needed when working horizontal hives.
Awesome.
Thank you so much.
Yeah.
Oh,
That was
you're
really
welcome.
interesting. Really interesting. Any last questions from anybody on the call?
I just want to pop in and say your hives are beautifully painted. I think you mentioned that your family paints them and they're wonderful artists. So I just really enjoyed all the
Yeah, let
paintings.
me mention something about painting. You know, first we were painting right on the wall of the hive. And even if you use exterior acrylic paint that's rated for exposure to the weather and sun, after a few years, it starts fading away. And it was a shame to use this artwork. So now that when they paint new beehives, they paint on canvas, and we scan it, and this way we're able to print it on aluminum and just attach an aluminum plate to the front of the beehive. And this way we can make as many copies as we like, and actually some of these paintings are available for sale on horizontalhive.com.
Oh,
and
wow.
eventually when the artwork fades, you can print another copy, so it will last forever. If you paint your box, I have a very quick tip. Use exterior acrylic paint that's not sold as crafts in craft section of the store, but the one that's actually sold in honey improvement, in home improvement section, like the exterior house paint. You can just make a few of the colors in small containers and then mix the rest. But this exterior house paint that's used for painting houses really lasts much longer than exterior grade craft paint. And then for additional protection, you can apply a layer of polyurethane, but you need to wait 30 days before you do so, because if the acrylic paint is not fully cured before you apply polyurethane, it will turn yellow on you. There will be pronounced yellowish tint to your artwork because there would be chemical reaction between polyurethane and the acrylic. It will not happen if you wait 30 days.
Great tip. Thank you. There's a lot of people chiming in on the chat to say thank you. It was a wonderful presentation, and people really loved seeing pictures of your family, and appreciate what a great family guy you are too. So
yeah, I have a
thank you
quick
so much.
question. I can't seem to make my chat work. Do you ever split hives, or you just depend on them swarming?
See, for many years, I was just depending on swarming. If I don't catch a swarm, they would go into a swarm trap, and I will just collect them in a swarm trap. But see, I live in a wooded area. There are miles and miles of forest all around. So I know for sure that probably at least half of my swarms will not go into my swamp traps because they have so many hollow trees in the woods to choose from. And I reached a point when I saw that to make my apiary sustainable and to have honey and to be able to sell bees and to replenish my own losses. By the way, natural beekeeping doesn't mean that you will never lose a single hive. There are some years where you will have heavy losses, but the wild bees in the woods will also have very heavy losses. So it just fluctuates. Anyway, so to replenish your losses and to have honey and even bees to sell, I eventually started practicing what is called in the old books artificial swarming. This is when you make a split, but instead of giving bees the queen in a cage that you purchase from a completely different climate, you allow them to raise their own queen, or you give them a queen that you raised from your own stock that's locally acclimated. So yes, I make these artificial swarms of splits. And by the way, in the books that I referenced, there are many techniques for doing it very easily in a horizontal hive. For example, the easiest way of making a split in a horizontal hive in the spring, when they build up the brood chamber to at least 8 frames of brood, you can take a solid divider board and just put half of the frames with brood and making sure that there are some eggs there to one side, and then divider, and then the rest of the brood chamber on the other side. You don't even have to find the queen. Without finding the queen, you know that half of the brood will find themselves queenless, and they will raise themselves a new queen. After a month, you check both halves to make sure there are eggs. If there are eggs in each half, you know that they requeen themselves, and they will keep growing from there. If for some reason the split failed, you lost nothing because you can just remove the divider board and merge them back together. And by the way, one of the benefits of doing this split inside one box, if you do it in an insulated box in the early spring when the nights can still be cold, the 2 colonies, the mother colony and the split, when they occupy the same box across the plywood divider, they're sharing the heat, and actually the success rate of the splits like that they take is higher than if you were to transfer these brood frames in a separate new box where they would need to heat themselves on their own.
Very interesting. Awesome. Well, thank you. I know it's late over there. I appreciate you staying up to talk with us. Yeah, thank you very much. If nobody else has any other questions, I think we'll let you go, Dr. Leo.
Okay, my pleasure. Thank you for having me on.
Yeah, absolutely. All right. We'll talk to you later. Bye. Bye, everyone.
Bye-bye.